Our next lesson is called The Purpose of Statistics. This is the start of our statistics chapter. So statistics is a branch of math that is quite different than most others because it contains tools that help answer questions that involve variability. We have mostly used math to answer questions where there is a single numerical result or a single answer. This is not the case when we use the tools of statistics to answer a question. So variability means change within answers. So in exercise number 1, Sophia is deciding on her college major and is considering computer science. She would like to explore a career as a phone app developer and is trying to answer the question, how much money do phone app developers make in a year? So first off, some vocabulary. Why is this a statistical question? So this is because not all people are going to make the same amount of money, right? So there's definitely going to be variability in this question because the answers are all going to be different. So we'll say this is because not all phone app developers make the same amount of money. So that means there's variation in the answers. So there is variation in the answers. So part B, what are some sources of variability in this scenario? So what would be some reasons why the answer to how much money you make would be different per person? So this could come down to years of experience. Maybe people who have worked longer make more money. This could come down to who you work for. So that's your employer. It could depend on how good you are at it, right? So talent. It also could depend on where you live or where you work. So I would say location. Depends on where you are. Sometimes depending on where you live, you make more or make less because of that. So moving on, to answer statistical questions, we often take a sample from a larger population to examine. We hope to use the statistics from just the sample to infer properties about the population kind of as a whole. So looking at exercise 2, Sophia decides to narrow her question down to the following. How much money do beginner phone app developers make in a year? So part A, why will Sophia have to work with a sample and not the entire population for this question? So how much money do beginner phone app developers make in a year? I bet you there are a lot of beginner phone app developers. There's no way she could ask every single person, so we're just going to take a sample. So under why will Sophia want to work with a sample, we're going to put it would be impossible to collect the salaries of every single one of these people. So every beginning app developer. And in part B, how will the size of the sample that Sophia uses affect her ability to draw conclusions about the population she is interested in? So you got to think about it this way. The size, draw conclusions. I mean, the bigger the sample, the more people, the more confident she will be. If she only has 2 or 3 people, she'll have 2 or 3 answers. But if she were to ask like maybe 20 to 30, she'll have more examples of answers and she'll probably be able to make better decision with a larger sample size. So we will write the bigger the sample size, the more confident she will be in her conclusions. In example 3, so we've kind of started with the beginning, like what even is a statistical question? It's because there's variability. How might variability look? And we used a specific example to go over that. We just referred to the fact that we cannot ask every single person or that fits the category. So we have to take a sample space, and we do need to make sure it's enough people to at least draw a meaningful conclusion. So we're kind of walking ourselves through the process of this whole idea of statistics. So the next thing that would make sense is that Sophia actually collects data. So let's move to exercise 3. Sophia takes a random sample of 20 beginning salaries for phone app developers. The data is shown below in thousands of dollars per year. So here's her sample size, 20 people, so not just a couple and not the whole population, a nice sample of 20. And you can see all of her data is listed here. So it says, list some statistics that you have learned about in previous grades that would help Sophia start to answer her statistical question from exercise 2. So if you want, you can pause the video here and kind of brainstorm what do you remember from past years about statistics. And then when you're ready to resume, you can go over the answers with me. So what I'm thinking here is hopefully you remember that you learned about median and mean. So middle and average, and we're going to talk a little bit more about that in a second. And what this does is it tells you what a typical number is like. Now, of course, you were brainstorming. I don't think you would have all of this. If you had median, great. If you had mean, great. If you didn't have these things, please add it. Other things that you've done previously, you did minimum. That goes along with maximum. So your lowest, your highest. You have had experience in previous grades with range. So what's the difference between your highest and your lowest? You also learned about interquartile range. Maybe even referred to as, we are going to refer to it as IQR. And all of those things that you learned about was about the variability of the set. So statistical question, the need for a sample. Here's our sample of 20 responses, and then an opportunity for you to think back on what you've already learned with statistics in the past. So now in exercise 4, Sophia would like to visualize how the data from her sample is distributed. Sometimes it can be hard to see what's really going on when you are looking at just a list of numbers that are kind of random and all over the place. They're not in order. So to visualize it, you'll get a better idea of what's really going on. So we're going to do that by making a dot plot of Sophia's data set. So when you're making this dot plot, I'm going to start it with you and then you can finish and resume the video to check. You are going to stack dots of the same value. So I'll start with you to do a few so you can kind of see how you're placing it. And just remember, if you get to one that's more than one, you stack them. So for example, 57, I'm going to look at my scale. I see it's going by ones. So 57 would be my first dot here. Then I've got 44. Then 52. Then 49. Then I get 53. Then I get 50, 54. And I'm going to continue doing this. So why don't you pause the video, make the rest of the dot plot yourself, and then resume the video to go over the answers. Okay, so you've made the rest of the dot plot yourself. Remember, you should have stacked the dots of the same value. Here's what your dot plot should look like. Now, if you're worried about missing any points, I would suggest maybe once you make your dot plot, you go back through and check that you had everything. I also think it's a good idea to count the number of dots. You know you're supposed to have 20 people that you asked, 20 data points. So make sure you have 20 dots. So now that we actually can visualize what's going on, it's easier to see where most of the scores are falling. So yes, we can see it better now, but there's actually some data that we can take and collect based off our 20 pieces of data here that will help us figure out what's going on. So we're going to summarize the data in her sample. And it says Sophia would like to calculate the two primary measures of central tendency for the data set, which is the mean and the median. So first, let's talk about how the mean is calculated. When you learned about mean originally, you learned that mean is the same as average. So if that's the case, that means you're going to add all the data and divide the total by the number of pieces of data. And underneath, we'll just put a little star that says same as average. So you would go back up here to all your data, you would add it all up, and then you would divide by 20 because that was the number of data points that we had. And that would give you your mean or average. That's what you always used to do for average. But now that we're in algebra, we have our graphing calculator that has a wonderful statistics package that will calculate a lot of these things for us. So today we're going to learn how to use that. We're going to use the calculator statistics package to find the mean of the data set. So look to the right here, and you will see the directions and calculator help for doing this. So the first thing we have to do is enter the data into what's called a list. We're going to put all 20 values in there, and then we are going to calculate the one variable statistics. In that list, it will provide us with the number for our mean. So we will go over to the graphing calculator now. Please grab yours, and I'll walk you through how to do this. So we are going to go to Stat, and then we are going to pick option 1, which is Edit. If there's anything in that list currently, you're going to go up to L1, hit Clear, and Enter, and it will clear out all of the data points. Now we're going to enter all of our numbers. So at this time, please type in by typing the number like 57 and enter, then 44 and enter. I want you to type in all of your values. You can pause the video and do that, and then resume the video once you have entered all your data points for L1. Okay, now that you are able to do that, make sure that you have 20. I can tell from my list because it says underneath L1 21, and that's the first blank under where I was. If I go back up one, I see that I'm at 20th one is 52. So I know I've entered them all correctly. Now to calculate the one variable stats, like in the picture on your notes, you are going to press Stat. And this time we're not editing. We already have the list in. Across the top, you can see that Calculate is next. So we're going to arrow over to the right where it says Calculate, and we are going to pick choice 1. So we want to make sure that it is the correct list. Under list, it says L1. That's all we need. We only have data in L1. If you happen to have the wrong list there, you can change it by, if you look at the number keys above it in blue, are all your L1s, L2s, L3s. Those are just different lists. You can type a bunch in at one time. So if you have the wrong one, you would just hit second and then type in whatever one you need. We have the correct one, so we're going to hit enter, and it's going to calculate a bunch of information for us. I'm going to scroll, and you can see I've got all these values. So that top one that looks like an X with a bar over the top, that is your mean. So let's go back and record that in our notes. I want to make sure you recognize that mean is this symbol. And so the mean for our data is 50.8. Now you might be thinking, well, geez, I could have added those up and divided by 20 faster. Once you get the hang of this and you realize all the other information that it immediately gives us, this is absolutely the best way to go. So that 50.8 means we have $50.8 thousand per year. Because remember, this was in $1,000. So $1,000 per year. So obviously we would write that like 50,800. That's what it would be, okay? Now, how is the median of a data set found? So for median, when you learned about this, the data has to be in order. So that's the first thing we want to make sure we know. So sort the data in order. That definitely takes time. You have to go up there and make sure you don't forget any and then relist them all. So this is where, again, the graphing calculator is so much more efficient. Doesn't matter what order it's in, the statistics package will figure that out and figure out your median for you. But if you used to do it by hand, you had to put it in order and then find the middle. So, and find the middle piece of data. Now, if again we use our calculator package, it tells us. So I'm not going to walk you through those steps again because we entered all that data once and already calculated the one variable statistics, it's there. So let's go look at our graphing calculator. If we look from where we were, there's the mean. I'm going to scroll down until I see MED. Now, you are going to hit the down arrow to do that. And when I look across from MED is for median, and it is 52. So we can just record our answer. So median is going to be MED on the calculator, and our median is 52. So that means it's $52,000 per year. Which obviously would be written like that. So it's amazing that this graphing calculator does all that work for us. So now let's move on and see what else the graphing calculator has given us and what it tells us. So this was our measures of central tendency, mean and median. And it also gives us some information about our variation. And so in exercise 6, Sophia would like to get a sense for the amount of variation. So remember what variation is, change. There is in the data, differences. One method for doing this is known as the range of the data set. Fill in each of the following for Sophia's data set. So again, we already have all this information. You only have to enter that data once and calculate the one variable stats once, and everything is given to you. So let's go see what it says. Min, max, and range. Min is 42 and the max is 58. So on the calculator, you'll look for min, you'll look for max, and then to find the range, you got to do that yourself. You're going to do the max minus the min. So for us, that was 58 minus 42, so that's 16. Exercise 7, Sophia knows the range gives her an idea of how her entire data set is spread out. She's also, though, interested in how just the middle 50% is spread. And the reason she's interested in that is because that's going to represent the most typical values in the data set. For this, she needs to calculate the interquartile range, or IQR. So let's write that underneath. We're going to fill in each of the following for Sophia's data set. Again, we already know it. So we're going to go back and get it from the calculator. We're going to look for Q1 and Q3. Looking at that kind of 5-point summary that's underneath the mean information, we can see we already had the min and max. We got the median. Q1 is 48. Q3 is 52. So we'll record Q1 as 48, Q3 as 53, and then IQR is going to be taking Q3 and minusing Q1. So for us, that's 53 minus 48, which gives us a value of 5. So I do want to go back and highlight a couple of things here. Remember, IQR was because she wanted just the middle 50% of the spread. And the reason is because that's the most typical values of the data set. So for that, we calculated the IQR, which I showed you in that last spot. So finally, after getting all the way from the statistical question, understanding the way it could be variation in this statistical question, understanding what a sample is, using a sample set of data to find the measures of mean and median, and then take it a step further and find the variation and what they know about the range in the middle 50%, we have all this data now that we can go and answer exercise number 8. Using some of the statistics you have calculated in the previous exercises, make a statement that starts to answer Sophia's question. How much money do beginner phone app developers make in a year? So this is where we are going to summarize all the info. So we're talking about beginner phone app developers. So we'll say beginner phone app developers make a mean or average, salary of $50,800 and a median, which is median salary of $52,000. So Sophia can expect to make, so we'll take a look at the next thing we found, min and max. So we know Sophia can expect to make a minimum of $52,000. Nope. Sorry, that was $42,000. And a maximum I go up and look, of $58,000. And then that IQR information told us about the middle 50%. So let's summarize that now. We know 50% of developers make from $48,000 to $53,000 per year. So we have all this information now that will help Sophia kind of get an idea of what's going on in this career path and possibly make some conclusions based on that. So in summary, let's talk about a few things here at the end. Statistics is the collecting, organizing, analyzing, and interpreting data in order to make decisions. Statistics is more than simply another branch of mathematics. It is the bridge that connects math, science, and social science. An interesting feature of statistics is there may be more than one correct answer. It's the variability of correct answers that leads to the procedures used in statistics. You're already familiar with many of the practices. In this unit, we will practice and introduce new concepts with the help of the graphing calculator. So you saw what a wonderful job that does of crunching all the numbers for us and giving the information quickly so we can use it. When dealing with statistics in relation to real data, research suggests that the process of creating and solving statistical problems is best accomplished when the following 4 steps are followed. So first, you want to plan and ask a question. Remember, we know it's a statistical question because of the variability in answers. You want to collect and produce data. So keep in mind, we want to use a sample. There's no way we can ask the question to the entire population. So we get a nice sample. We then process and analyze that data. So we calculate the mean, the median. We find the min and max and range. We find the Q1, the first quartile, the third quartile, and we find the IQR. We get all this information. Then we can analyze the data in order to discuss and interpret the results. So this concludes our first lesson in the statistics chapter, the purpose of statistics.